Yeah, good morning. Just we are going to talk about 8051 interrupts in continuation with the previous features of microcontroller, which is IO ports and timers and serial communication. Now we are going to talk about the interrupts concept from your 8051. Okay, so this 8051 microcontroller, which is going to provide different kinds of interrupt lines. So from your microcontroller, which is 40 pin 8051 device. So this 8051 microcontroller, which have as an inbuilt feature this interrupts concept. So generally how the people will treat these interrupts as a feature or as a one of the topic from this device. Generally this interrupt means general meaning of interrupt from your microcontroller is like you can consider as a disturbance, or you can consider as a unwanted signal for the device. But coming to the application developers, they are going to treat this interrupt is also one of the feature for your device. But coming to the general meaning of this interrupt, which should be your unwanted signal, or it is a disturbance signal for your device. Why the people are considering this is one of the best feature from the microcontroller families? Why? Because so coming to this application development, the people will need different operations on different conditions. Generally, if you develop a program with general if conditions, so this if, like whenever you are looking to write some 10 conditions in the application, so what is our approachment? Our people will follow this if else conditions, right? So if one condition is not satisfied, then the compiler will go for second one, and if second one is not satisfied, then the compiler will go for third one, and if the third one is not satisfied, then it will go for keep on checking the multiple conditions in the program, right? Okay, so at this situation, now if suppose if first condition is true from your application part, at the same time if the ninth condition is also true, then what the compiler situation? Okay, so now the first condition which is satisfied and which is compiling these conditions at the same time, so the ninth condition of your program which is also satisfied, then so the compiler which has to finish this compilation and then it has to go for the ninth condition, right? Okay, until unless which is not finishing your first condition, it is not it doesn't mean, so which never go for this ninth condition directly. Okay, so this is the problem for your general if conditions or if else conditions in the application development, right? Okay, so at this situation, whenever you are looking to perform some applications with your device, like our people have to follow different methods. Like suppose I have 10 patients for one doctor. He is going to monitor for every 1 hour. He is going to monitor the 10 patients conditions, and he is come back and he will sit, and again he will go for the next hour and he will check the conditions. Okay, so at this situation, now he is going to check the third person, and 8th person needs some emergency. Then he has to stop this general process and he has to go immediately for this ninth person, and he has to fill this emergency and it has to come back for general process, right? So the same task if you are assigning for your microcontrollers, then if you want to do our application with your microcontroller, because it is an electronic device, so you people have to program this what way it has to do. Okay, so this process whenever you are looking to implement with this controller families, then you people have to go for this interrupts concept from the device. So these interrupts which are help us whenever your application has the major importance, or whenever your application has some emergency in the application execution process, then you people can pick this interrupt feature from the device. So the same task how this microcontroller will do this, or the same task which will be how it will perform in the microcontroller itself, which is going to provide 6 interrupt resources for us. So what are these 6 interrupts for us, and what way you can use these interrupts for our applications purpose? So now let us discuss. So these 6 interrupts which are which are divided into two types. One is 3 hardware interrupts and 3 software interrupts. So what is meant by hardware interrupt here, and what is meant by software interrupt? Like hardware interrupt means whenever you people are going to provide an external signal from outside. So external signal means, so you people have to provide the signal from sensor, or signal from switch, or signal from any hardware resource. Like hardware resource means based on our input devices or based on our modules. So whatever the way you people are looking to do a important process in your application, then you people can depend on this hardware interrupt signals. And what about these 3 software interrupt resources for your device? So software interrupt means whenever your process is going to keep on executing, then whenever you are going to come out, suppose the device is doing your process in an infinite time, okay, suppose once you assign one task for 5 minutes, then which is keep on executing even after 5 minutes also, then you are going to break that process, then you people can use this software interrupts from the device. So these software interrupts, the system itself, it will generate some kinds of logic levels or logic of, it is going to change the bits logics, then according to that your process will terminates or your process will starts. Okay, so these are the 3 software interrupts for your 8051 and these 3 are the hardware interrupts for your 8051. Okay, so what are the names of these 3 hardware interrupts from the 8051, which is they are going to give reset and INT0 and INT1. So these are the 3 hardware interrupts for your 8051 family. And what about these 3 software interrupts, which are timer 0 and timer 1 and serial interrupt, which should be TI or RI. So these are the 3 software resources for you and these are the 3 hardware interrupt resources for you. Okay, so but generally people won't consider the reset is also one of the programmable interrupt, but coming to the advanced microcontrollers, there is even software reset which should be watchdog timer. With the help of this watchdog timer or BOD, brownout detection, with all these things you people can consider this reset is also one of the interrupt resource. Okay, but in 8051 case, which is not possible to use, so which is not possible to use this reset as a programmable interrupt, but the remaining 5 interrupts you people can use for programming purpose, which is INT0, INT1 and timer 0 and timer 1 and serial. So these are the 5 names of your interrupt resources for your 8051. So how you people can make this 5 interrupts from the 8051, which is if you are looking to use these 5 interrupts for a program purpose, then you people have to depend on the programmable resistors, which is IE, IP and TCON. So these are the 3 SFR registers which are used to program your interrupts concept, and these are the 5 interrupt resources for you. And what is the order for this interrupt? Suppose you people are generating this 5 interrupts at a time, then what the microcontroller will prefer and which one give the most priority. For this also there is a default order for your interrupt signals, like the first which is going to prefer INT0, and next it will prefer timer 0, and next it will prefer INT1, and next it will prefer timer 1, and next it will prefer serial interrupt TI or RI. So this is the priority order for your device. So this priority order it will follows always. This is the default priority order for your interrupt signals. Suppose you people are generating this 6, the first interrupt you are going to generate INT0, and when it will prefer this INT0, then it doesn't, next it will give the preference for next timer 0, next it will give the preference for INT1, next it will give the preference for timer 1, and next it will prefers to serial interrupt, which is TI or RI. So these are the 5 programmable interrupts which are going to use for us. And whenever, so how this hardware interrupts you people can generate and what way it will consider, like when this INT0 task will execute, and when this timer 0 task will execute, and when this INT1 task will execute. Like according to this, when this INT0 task which is going to execute, whenever you people are going to generate one high to low pulse, like high to low pulse means, so from our microcontroller pin diagram, so where you can find this INT0, which is the 12th pin of the device, which will be P3.2, right? And this is your INT0 number, and where you can find this INT1. So here also you have to give this high to low pulse in the same way, which should be 13, P3.3. So these are the 2 hardware interrupt lines you can use whenever you are looking to generate hardware interrupts. Okay, so except this timer 0, because this timer 0, timer 1 and serial interrupt which you can generate through program only. Okay, so whenever you people are generating this high to low pulse from this 12th pin, then so it will consider the priority task, and so which will give the most important priority for this INT0. Then what way your program is going to execute? suppose you people wrote the program for your microcontroller, it should be main program, and whenever you are looking to interrupt service routine, so this interrupt service routine means which should be a part of your INT 0 or timer 0 or INT 1 or timer 1 or TARRE. Okay, and always this interrupt service routine is the independent of main program, because so you don't know when it will execute. So that is the best relation you people can find. So whenever you are, suppose there is a program in the same way, like there is a main program and there is a general function or subroutine. So generally the difference between ISR and function and subroutine is, so this function which is going to execute whenever you are going to call anywhere in the program. Suppose if I am calling here, so then it will come here for this function and it will execute and it will go back. And again whenever you are looking to call this function, and again it will come and it will execute and it will go back. But this interrupt service routine is, it is a purely independent of main program. You people don't know when it will comes, and whatever it is doing, suppose the main program which is doing some task, okay, so once the interrupt signal which is given to the microcontroller, then it will directly comes to this ISR and it will execute and it will go back. See, it is going to stop this process until unless you people are not generating any interrupt signal from outside, which is keep on executing this main program process, or which is going to execute your main program, like if you are executing the infinite times, which is going to execute infinite times. But coming to this execution process, so the subroutine or function, it is a part of your main program, because I divided my task into two ways, like a functions, or you people can use different concepts in programming, right? Okay, so whenever you are looking to use this function concept with the in the programming part, so whenever you are calling from main and it will execute and it will go back as usual. But coming to this interrupt service routine, which is a purely independent of main program, and the task is also not related to interrupt service routine. I can do any other important task as per my application requirement. Okay, so this is the way the interrupts will execute in the microcontroller. And again, this interrupt also follows some interrupt vector table. So this interrupt vector table, which should be a for every interrupt according to the memory, like suppose you people are writing this ISR, so this ISR has a fixed address in the memory, because all the programs or all the data storage where it will happens in the device, which is going to store in the memory only, right? Okay, so but for your general functions, which is always out of the main program, and they will store after main program storage locations. But coming to this interrupt service routine, so they are going to store in a fixed memory locations. So for your INT 0, there is a fixed address for your device, which should be 0003H, and for your timer 0, which is going to store with 000BH, and next for your INT 1, which is going to store with 0013H, and next which is going to store your timer 1 ISR in 001BH, and coming to serial interrupt, which is going to store with 0023H, and obviously the address of reset is what? 0000H. Okay, so these are the default addresses, or the considered memory address locations for your all interrupts from the device. So these are the 6 interrupt resources you people can use, and whenever you are looking to write the program by using interrupts, then this program storage will be starts from these locations. That's what. And if you observe these location sizes from INT 0 to timer 0, it should be very small. So that is the reason whenever you are going to choose all the interrupt signals from your device, so the task what you are writing from this ISR, it should be very small. Like it is not possible to write a lengthy programs for your interrupt service routines. Thank you.